Welcome to this M1 video on solving problems involving velocity and time using vectors. So this time we're going to bring in a position vector. Okay, so we can give a position vector from where a particle starts, and position vector is usually the letter R. So its initial position vector will be RO. Okay, then velocity times time will be the displacement. So if I think about the new position vector R, it'll be the starting position vector plus its displacement. So R equals RO plus VT. And this is what we're going to be introducing now. And don't forget, we still have things like V equals U plus AT or F equals MA. Okay, and all of these things can still be dealt with as vectors. Okay, remember the vector just has the direction as well as the magnitude, rather than just the magnitude on its own. But let's get into a few examples, as it's easier to explain with some questions. So we have this one. Particle starts from a point with position vector 4i plus 5j and moves with constant velocity of 3i minus j. Find the position vector of the particle after 3 seconds. So we want R, and it's RO plus VT. So RO is 4i plus 5j. And then VT, well, time is 3 seconds. And the velocity is 3i minus j. So we've got 4i plus 5j plus 9i minus 3j. So that's going to give me 13i plus 2j. And that is the new position vector of the particle after 3 seconds. So it's just the starting position plus the displacement. Okay, hopefully that made sense there. And lots of these questions, they're going to be parts of larger questions when we've covered more of this content. Now, let's have a look at the next example. So in this one, it's just like not the reverse, but kind of the reverse of the last one. So we've got a particle moving with constant velocity. At t equals 0, its position vector is this. 4 seconds later, it is at the point of position vector this. Find the velocity of the particle. So if you think about it, R equals RO plus VT. R is going to be 25i plus 2j. RO is going to be 5i minus 2j. The time is 4 and the velocity is what we want to find. So that means we're doing 25i plus 2j minus 5i minus 2j. Okay, so 25i minus 5i is 20i, and 2j minus 2j is plus 4j. And then we want to divide by 4, so v is equal to, dividing by 4, we get 5i plus j. And that there is the velocity. There's a few ways in which you can do it without using the formula. Just, find the find the displacement. So, you know, if you find the displacement, it is doing this takeaway, the difference, and then dividing by 4 because it's 4 seconds. So you can set it out not in a formula, just, you know, logically, but hopefully you're able to follow this okay. So that's the next kind of little bit of a question. Right, let's have a look at another one. Hopefully I'm not going too fast. Okay, at time t equals 0, a particle has position vector 7i plus 4j, just put that in brackets, and is moving with a speed of 26 meters per second in the direction of 5i minus 12j. Find its position vector after 3 seconds. So first we have the direction, 5i minus 12j. Okay, so 5i minus 12j is the direction. And what we want is 1 unit in that direction. So first we want to find the magnitude. So magnitude. So that's 5 squared plus minus 12 squared, which is square root of 169, which is 13. Okay, so 1 unit, a unit vector, in the direction of motion will be 1 over 13 5i minus 12j. Okay, because what we're doing is, you know, we're going 5 across, 12 down, which is currently 13, but we want this value to be 1. So we divide by 13 to get just a small, you know, unit, 1 unit in that same direction. Okay, it's important to do that. Just rub that out. So now I can work out what the velocity is. So the velocity is 26 meters per second in this direction. So that is going to be 10i minus 24j. So that now is my new velocity. Okay, so now we go on to using our formula, R equals RO plus VT. RO is 7i plus 4j, the original starting position, plus, now it's for 3 seconds, so 3 times 10i minus 24j. So 7i plus 4j plus 30i minus 72j, which is 37i minus 68j. So that therefore is the new position. So hopefully that makes sense, because we had the speed and we had the direction, but for the direction you need the direction, then you need to find 1 unit in that direction. Okay, so that will always be the direction divided by the magnitude of that direction to find 1 unit, okay, in that direction. So hopefully that makes sense. Okay, and now we can have a look at the next question or example. Okay, so this one has a velocity of 2I minus j at t equals 0, moves a constant acceleration of I plus 3j. Find the speed of the particle after 5 seconds. So this is one where we use our Suvat equations because it has an initial velocity of 2I minus j. We want to find v after 5 seconds, where t is 5 and a is I plus 3j. So this is v equals u plus at. So it's 2I minus j plus 5 times I plus 3j. So 2I minus j plus 5I plus 15j. So that's 7I plus 14j. Now we want the speed and not the velocity. So we want the speed, which is the magnitude of the velocity. So 7 squared plus 14 squared, and then square rooted. So just go into my calculator. And that is 7 root 5 or 15.7 meters per second. And that's the 3 significant figures. Okay, so you know, the Suvat equations, they still work even when you're dealing in vectors. You still use them exactly the same way. Okay, the next one is an F equals ma question. Okay, so we've got a constant force acts on a particle of mass 4 kilograms for 5 seconds. The particle is initially at rest, and 5 seconds later it has a velocity of 15I minus 8j. Find the force. So its final velocity of 15I minus 8j was for 5 seconds times an acceleration a. Okay, because when you start off with the initial speed plus 5 times the acceleration, you would get this end speed. So this is what we've got. So therefore a is dividing this by 5, 3I, and then 8 over 5 is 1.6j. So that there is my acceleration. Okay, and it comes from v equals u plus at, where v is, you know, the 15I minus 8j. Let's throw the j there. U is 0, t is 5, and a we're trying to find. Okay, but anyway, right. So now I've got the acceleration, I want to find the force. So F equals ma. The mass is 4 and a is this, isn't it? 3I minus 1.6j. So that's 12I minus 6.4j, and that there is in newtons. And you can leave it like that. Obviously, if it said find the force, the magnitude of the force, then, you know, we'd have to find the magnitude of that, which is 13.6 newtons. Okay, so if we had to find the magnitude, we'd square this, add them together, and then square root. Okay, but it doesn't say find the magnitude, it just says find F, so we can leave that as a vector. Hopefully you found these examples useful and helpful for you. If you did and you're not a subscriber, hit that subscribe button if you want more of my videos. Hit the like button if you found this useful, and if you want to help me out, hit that join button. Otherwise, let's look at a few questions. So there's lots of questions for you to practice in your textbooks. I've just got 4 questions here for you to have a little go at, a little bit like the examples and one slightly different. Have a go at these 4 questions and then stick around for the answers at the end. So pause the video now. Okay, hopefully you've done these 4 questions. Let's look at the answers. So here we have a similar question to the last example. So the particle is initially at rest. 10 seconds later has a velocity of 8I minus 6j. T equals 10 and A we want to find. So V equals U plus AT. 8I minus 6j equals 0 plus 10a. So a is dividing this by 10, so 0.8i minus 0.6j. And then we want F. So F equals ma. The mass is 2 and the acceleration is 0.8i minus 0.6j. So that's 1.6i minus 1.2j newtons. Okay, and that's that question done. So this one, we start with position vector 5i plus 8j. We move with constant velocity 2i plus 3j, and time is equal to 4 seconds. We want the position vector, so r equals r0 plus vt. So 5i plus 8j plus 4 times 2i plus 3j. So that's 5i plus 8j plus 8i plus 12j. So that is 13i plus 20j. And that is the position vector. So we have initial position vector of 10i minus 3j. Time is equal to 8, and the position vector of r is 26i plus 5j. And we need to find the velocity, so r equals r0 plus vt. So 26i plus 5j is equal to 10i minus 3j plus v, or 8v. So 26i plus 5j minus the 10i minus 3j. So 26 minus 10 gives me 16i plus 8j. And then dividing by 8, we get 2i plus j. And that is the velocity in meters per second. Let's have a look at the final question. Okay, I'll probably do a little sketch for this one. So if we think of the observation point, call this O, spots a dinghy, 400 meters due north, and then it has a velocity of -2, 3. So velocity in that kind of direction there, -2I plus 3j. Find the distance of the dinghy from the observation point at 304. So we need to find, how far this way it's gone. So if I assume the observation point is the origin, its starting position is 400 meters north. So R0 is 0I plus 400j. Its velocity is -2I plus 3j. And then the time is 4 times 60 for that in seconds, so 122.40. So R is going to be 400j plus 240 times -2I plus 3j. So 400j minus 480I plus 720j, or minus 480I plus 1120j. So that is the position vector. We want the distance. So distance is going to be the modulus of this. So minus 480 squared plus 1120 squared, and then square root it. And that gives me 1218.5 meters from the observation point. Okay, and that's to 1 decimal place. Or 1,220 meters to 3 significant figures. However you want to round this off. And there we have the final question. Okay, and this is also the final bit of this chapter or unit. The next we'll be going on to dynamics of a particle moving in a straight line. So stick around for that video. Should be popping up on your screen about now.